So let's take a look at some of these systems of equations and see how we can solve them using our different methods. So we'll start off using the substitution method to do a few of these from the notes. So this first system, negative 10x plus 2y equals 6, and then negative 6x plus 3y is equal to 18. So remember the substitution method, you could take either one of the equations and solve it for either of the two variables and then plug that back into the other equation. So for example, I could take this top equation and pretty easily solve it for y. So I could get 2y is equal to 6 plus 10x, just adding 10x to both sides, then divide the whole thing by 2. And I'll get 3 plus 5x. Remember, you have to divide the 2 into both the 6 and into the 10. So now what I need to do is take this y value and plug it into the other equation. Don't plug it back into the one that you just solved for, or bad things will happen. Make sure you plug this back into the other equation. So if I substitute this into the second equation, instead of y, I'm going to replace it with 3 plus 5x, which is what y is equal to. And now I have an equation that's totally in terms of x, and so I can solve this equation for x. So we'll just do some simplification. Distribute out the 3, this will be 9 plus 15x is equal to 18. Negative 6 plus 15 is going to be 9, so this is 9x. 18 minus 9 is also 9. So 9x equals 9, that means that x is equal to 1. So that gets me the solution for my x value. Now to solve for the y value, plug x equals 1 and back into either one of these equations. It doesn't matter which one, whatever is the easiest. And in fact, you can even plug it into this version. This is a version of this equation, right? So I could even plug it back into here for x. 5 times 1 plus 3y should be equal to 8. But if you might not like doing that, just plug it back into one of the original equations. It's usually the easiest thing. So I'll plug in x equals 1 for the negative 10x plus 2y. So I'll get negative 10 plus 2y is equal to 6. So 2y is equal to 16. So that means that y is 8, just like I predicted a second ago. So my solution set to this is x equals 1, y equals 8. Let's try another one. Let's try another example. 5x minus 24y is equal to negative 12. 17x minus 24y is equal to 36. Again, we can take either equation, solve it for either variable. It doesn't matter which. Both of these, it looks like no matter which one we solve for which variable, we're probably going to end up with some fractions. So I'm just going to take the top equation and solve it for y. So move everything that doesn't have a y over to one side. So negative 12 minus 5x, and now I'll divide everything through by negative 24. So this will be y is equal to a positive 1/2 plus 5 over 24x. Again, this looks kind of nasty. It doesn't look like a very nice equation, but if you notice, whenever we plug that value in here, we're going to multiply by 24. And then 24 times 1/2 is 12, which is fine. And then 24 times 5 over 24, the 24s will cancel out. So actually, this won't be too bad. So we'll take this y, substitute it in here. So instead of y, I'll replace it with 1/2 plus 5 over 24x, and all of that is equal to 36. Again, I have an equation that has just one variable in it, and so I can solve it for that variable. All we have is an x. So let's clean this up a little bit. Negative 24 times 1/2 is negative 12. Negative 24 times 5 over 24. The 24s will cancel out, which is negative 5x. And all of that's equal to 36. So 17 minus 5, that would be 12x. And then 36 plus 12 will be 48. The whole thing divided by 12 will get that x is equal to 4. That's one of our answers. Now to get the y value, just plug this back into any of these equations. So either of these two, or like I said before, this is the same equation as this. So why don't I just plug it straight into that equation? So y is equal to 1/2 plus 5 over 24 times x, or times 4 in this case. So that y is equal to 1/2. This will be plus 20 over 24, or which I can think of 5 over 6. Or I can do this, the 4 goes into 24 6 times, so they get 5 over 6. So this is really going to be 3 over 6 plus 5 over 6, so 8 over 6, which is the same thing as 4/3. So that's what y is equal to. X is equal to 4, so my solution looks like this. 4 4/3 for my solution set. Let's try one of these that doesn't have a solution, so something like this. This particular set of equations doesn't have a solution, and we'll see why. I'll go ahead and solve the bottom equation for y, because it looks like it's probably pretty easy to do that. Okay, so I'll move the x values over. Now I'll divide by 2, so y is equal to 1 minus 4x. And now I need to substitute this y into this equation. So 16x plus 4 times 1 minus 4x is equal to 28, which tells me that 16x plus 4 minus 16x is equal to 28. So I get 16x minus 16x, they go away, and I get this false statement 4 is equal to 28. That doesn't make any sense. So that tells me two things. Either I messed up somewhere, or there's no solutions to this set of equations. You'll never find an x and y value that work for both equations, the same x and y value. We'll compare that to this set of equations, which has infinitely many values that work, infinitely many solutions. Again, see, I'll just solve the top one for y, because that's pretty easy. I can just subtract over the 2x, and then substitute that in right here. So I'll get 6x plus 3 times 6 minus 2x is equal to 18. So 6x plus 3 times 6 is 18, minus 6y, or sorry, 6x. And so then I end up getting these cancel out and get a true statement. 18 is equal to 18. So this means that there are infinitely many solutions. In other words, no matter which values you plug in, if it works in one, it's going to work in the other as well. There's an infinite amount of values that are going to work for this particular one. Let's solve now, instead of using the substitution method, let's look at our elimination method and see a few of these examples. So we'll do this set, 3x plus y is equal to 6. 2x minus y is equal to 4. Remember, the idea of the elimination method is that you want to change, or maybe you won't have to, but you might need to change one or two of the variables by multiplying by some numbers, so that when you add the two equations together, one of the variables goes away. Now, in this particular case, we don't have to do anything, because if we notice here, if I add y to negative y, they go away and they become 0. So I actually don't need to do anything to this set of equations. I can just add them straight down. When I add y plus negative y, that becomes 0. 3x plus 2x, that's going to be 5x. And then 6 plus 4 is going to be 10. So it turns out that x equals 2. This one was pretty quick, even quicker than the substitution method. So now I can just take this and plug x equals 2 back into either one of the equations. Maybe I'll pick this one. So 2 times x minus y equals 4, so 2 times 2 times y equals 4. 4 minus y equals 4. That means that negative y is equal to 0, or that y just equals to 0. So we end up getting a solution of 2, 0. So you can see that sometimes the elimination method's a little faster, a little more efficient. Some problems will be easier with the substitution method, some problems is easier with the elimination method. The way that you'll learn which is just by doing a lot of them and trying and error. All right, let's try another one. So 4x plus 3y is equal to 8, and x minus 2y is equal to 13. I notice that if I multiply this x by a negative 4, that it will cancel out with this positive 4. So I can do that, but be careful, you have to multiply the entire thing times negative 4, so all parts of the equation. So this will become 4x plus 3y is equal to 8. And this will be negative 4x, and then negative 4 times negative 2y is a positive 8y. Negative 4 times 13, this will be a negative 52. And now, if I add these straight down, the x's will go away. 3y plus 8y is 11y. Negative 52 plus 8 will be a negative 44. And when I divide by 11, I get y is equal to negative 4. Now I can go back and plug in the y to, I wouldn't plug it into one of these because probably your numbers are bigger, but maybe go back to the original equation. So maybe go back to this one, x minus 2y is equal to 13. So x minus 2 times negative 4 is equal to 13. And now solve it for x. So this is x plus 8 is equal to 13. So x is equal to 5. So our solution ends up being x equals 5, y equals negative 4. Right, so we'll do one more. We'll have to change a little more stuff. So 4x minus 3y is equal to 25. Negative 3x plus 8y is equal to 10. In this case, I can't really just change one set of numbers, but I do notice that 4 and 3 are both multiples of 12. So if I could multiply this by a positive 3, I'll get a positive 12x. If I multiply this one by a positive 4, I'll have a negative 12x here. So let's try that. And remember, for these, there's several ways to work these problems. I could have also eliminated the y's by making these both 24, multiplying this by 8 and this times 3, and they would also cancel it out. So you can be creative. Whatever is the easiest way to do it, that's the way you should do it, the way you're going to make the least amount of mistakes. Okay, so if I multiply the top times 3, that 4x becomes 12x. 3 times 3 is 9, that's negative 9. And then 3 times 24 is 75. 4 times negative 3x is negative 12x. 4 times 8x is 32. Sorry, 4 times 8y is 32y. And then 4 times 10 is 40. Now when I add these straight down, the x's will go away. This will become 23y. And then this becomes this 7 plus 40. This will become 115. And then 115 divided by 23 is 5. Now I just need to take this and substitute it back into either one of my original equations. They're both about the same difficulty, so it doesn't matter which one. So this would be 4x minus 3 times 5 is equal to 25. So this would be 4x minus 15 is equal to 25. This 4x is equal to 40, so that means that x is equal to 10. I think in this one, on the notes, I might have done this in the opposite direction. I might have solved for x first, but this also works. So if it is a little different, then you can see two ways to solve the same problem and how to tackle these. Let's do a couple of these mixture problems. People tend to have problems sometimes setting these up. So that's typically the hardest part. If you can get it set up, then you just solve the system of equations like you normally have. But let's look at this first problem. We want to mix some coffees that sells for $4.55 a pound with some other coffee that sells for $5.95 a pound. And we want to mix it together in such a way that we get 20 pounds of coffee that sells for theoretically $5.35 a pound. So how much of each of these should you mix together, assuming that they mix together well to make coffee that's worth this amount? Well, the easiest way to do this, this is a little different than the way I'm doing it in the notes, is to come up with a system here. I'm first going to just define some variables, and we'll let x be the number of pounds of the 455 coffee. And I'll let y be the number of pounds of the 535 coffee. So I know when I mix this together, however much x I have, when I mix it with however many y's I have, that's the number of pounds of each. Whenever I mix them all together, I better get 20 pounds. So that's my goal to get to. Okay, so how much is each of these worth? Well, of the x value, these are $4.55 a pound. The y variety, this is worth $5.95 a pound. And when I mix it all together, I want to get something that is $5.35 a pound. From here, it should become pretty easy to see my two equations. The first one is just going to be that x plus y is equal to 20, because the number of pounds from the first one plus the number of pounds from the second one should equal to 20. The second equation is usually the harder one. It's how much it would cost if you bought x pounds of this coffee, how much would it cost? Plus, if you bought y pounds of this coffee, how much would it cost? It should equal to the cost of buying 20 pounds of the $5.35 coffee. So I can actually just multiply straight down. And I get 455x plus 5.95y should be equal to 5.35 times 20. And usually this times 20 is the one that people miss at the end. So make sure that you're getting that one. So from here I have my system of equations, and I just need to solve this. Again, this is just so you realize what this is if you bought x pounds of this coffee, this is how much it would cost total, right? If you bought 2 pounds, it'd be 2 times 455. Same thing with the y value. If you bought 3 pounds of that, it'd be 3 times 595. All of that should equal the cost of buying 25 pounds of the mixed coffee together, because that's what we're trying to do, is mix all this coffee together to make 20 pounds. So to solve this, I would use substitution method, just because it's pretty quick. I would solve the top equation for y equals 20 minus x, and then I can substitute that into the bottom equation. So 4.55x plus 595 times 20 minus x is equal to 5.35 times 20. If you do this, you'll get 119 here. So this would be 4.55x plus 119 minus 5.95. Oh, I'm sorry, then that should all equal to 5.35 times 20 is 107. So sorry, I have my cheat sheet over here with all the multiplication on it. So all of this should equal to 107. And then 455 minus 595 is negative 1.4. So now we're just doing some algebra. And then 107 minus 119 is going to be negative 12. And if you divide 12 by 1.4, we'll get approximately 8.57. So that's how many pounds of the 455 coffee we should mix in. And then we can use that to resubstitute in here to find out that y should be 11.45. And that should be the number of pounds we need. Remember, this is not the price, this is how many pounds of coffee. So those are our two mixtures that we should mix together. So this is a classic problem that we would use this for. Another classic type application is a mixture of either salts or acids. So for example, if I want to mix some 80% acid solution, 80% acid just means that it's 80% acid and 20% water. If I want to mix that with a 50% acid solution, so a solution that's half acid, half water, and I want to get 50 gallons of a 60% solution. You can see maybe this is a scenario in a lab or something where you only have these solutions of acid, but you need this 60% solution for some kind of experiment. How can I mix these together and get that much? Well, again, I'm going to use kind of my same method. I'm going to define some variables first. So x will be the amount of the 80% solution. Y will be the amount of the 50% solution. And so when I add these together, I better get 50 gallons because that's the amount of each that I'm going to pour together. I better end up with 50 gallons at the end. Well, I'm going to have an 80% solution here. That's the amount of have x. This is going to be a 50% solution, and then the 50 gallons at the end is going to be a 60% solution. So now I get two equations. I get that the total amount of solution that I have should be 50 gallons. So x plus y is 50. The second equation I get is a little strange. It's again, I can kind of do my multiplying down method, but you need to know what it means. If I have x gallons of solution and 80% of it is acid, then 80.80 times x is just the amount of it that's acid, right? If you have 10 gallons and 80% of it is acid, then 8 gallons of it is going to be acid. So 0.80 times x, or in this case, I could actually just write 0.8 times x, because I don't need that 0, plus 0.5 times y. Again, this is the amount of acid that's in a solution of size y, because like 10 gallons, 50% of it is acid, 5 gallons of it is acid, the rest of it is water. That all should equal to the amount of acid that's total in the 60% solution, which makes sense too, right? You're pouring two things together. There's a total of this much acid in here, total of this much acid in this one. When you put them together, the total acid is what you have in the leftover solution. So this one should be 50 times 0.6 for this problem. So that's where we're going to get our two equations from, and now we just need to solve these two equations. If you go through and do this, I'm not going to do all of the work on it, but you'll get that x is 50 over 3 gallons, or yeah, gallons. 50 over 3 gallons, and then y comes out to be 100 over 3 gallons. So I'll let you do the legwork on this. The main thing is I want to show you how to set this up. But in solving these, it's the same way as before. One thing that might help in solving, sometimes people like to go through and multiply this whole bottom one by 10 just to get rid of the decimals. If you like to do that, it's fine. Sometimes it makes solving the problem a little bit easier.